that does not deal with the left or the right, but it deals with using right down the middle, the midpoint, or MRAM. So again, I'm going to graph y equals x squared plus 1. Here's 1, here's 2. Same thing that we've done before. Using the same intervals, starting at 0, going to 2, bounded by the same region. But this time, instead of using the endpoints at 0, or at 1/2, or at 1, or 3/2, or 2, we're going to use numbers in between those, and we're going to use the numbers at 1/4, 3/4, 5/4, and 7/4 to create a rectangle. So at 1/4, right there, that dot that's on the y equals x squared plus 1 is the spot where I'm going to connect for the height of my rectangle. I'm going to bound it left and right a little bit, and so I'm going to use my rectangle there created from the height based off of 1/4. At 3/4, the graph would be here. I'm going to go back to get to the left side of the rectangle and go forward a little bit to the right side and create my rectangle down to 1 there. And you can see how on this one we have a little bit of overestimate, but we also still have a little underestimate. Next one's at 5/4, dot maybe go out there. Build my rectangle using the midpoint there. And the last one there, here at 7/4, okay, it hits the graph here of x squared plus 1, and we're going to calculate what that value is in a moment. I'm going to go to the right to build my rectangle this way. I'm going to go to the left, back to 3/2, and build it down that way. And so you can see each rectangle has a slight area of extra overestimate, but it also has an area of underestimate. And so this one might be a very good accurate answer for what the total one would be. And let's just figure out what that will be by doing the MRAM calculation. So each base is still 1/2, okay, not 1/4, but 1/2 still. We still went from 0 to 1/2, 1/2 to 1, 1 to 3/2, and 3/2 to 2. But this time the first value was the coordinate when we plugged in 1/4, which turns out to be 17/16. Then we have 1/2, and our next spot would have been at 3/4, which turns out to be 25/16. Next rectangle has a base of 1/2, and when you plug in the 5/4, you get 41/16. And the last one there was a 1/2 1/2 times 65/16. All right, and so again, 1/2 times all these numbers, if you add them up, will give you an area using the midpoint rectangular approximation. And this calculates to turn out to be 37/8, which if we want to compare it to the 1/4, let's just divide this by 2, and it's going to be 18.5 out of 4. And so that was right down the middle, very close to right down the middle between the left and the right RAM. All right. Let's try this example. Take a moment and try this on your own. Estimate the area under y equals negative x squared plus 4 over 0 to 2 with 4 equal subdivisions. You can try the left and the right RAM. Pause the video if you need more time. All right, let's take a look at the answer now. Your graph should look something like this. For LRAM, you should have 1/2 as the base for each one of those 4 subdivisions, and the numbers that you're plugging in would be 4, 15 over 4, 3, and 7/4. And so that should turn out to be a total of 25 over 4. For your RRAM, the base is still going to be 1/2, but this time the numbers are going to be 15 over 4, 3, 7 over 4, the same ones from before, but we're going to use the 0 that you would get from the height from 2. And so this time, the right side is actually smaller at 17/4. Another way you'll see these problems presented a lot are using tables. And so let's just take a look at a table real quick. The table shows the velocity of a model train engine moving along a track for 10 seconds. Estimate the distance traveled by the engine using 5 equal subdivisions for the MRAM. When we look at this problem here, you can see that there's 0 to 10 listed, but we're going to use 5 subdivisions, so that means each subdivision here should be a unit of 2 seconds. So from 0 to 2, 2 to 4, 4 to 6, 6 to 8, and 8 to 10. If I think about how big each base is, I don't really need to draw a graph, but I can see each one is 2 seconds long, so my base value here for each rectangle would be 2. Then we want to look at the midpoint, okay? So the midpoint of that first section is not from the 0 or the 2, but it's right here at the 1. And so the coordinate at that point would be the 12. My next midpoint in the next rectangle would be the value at 3, or 10. The third one comes from 5, which is 13. 7 is the midpoint of the next region, which is a value of 6. And the last one here comes from 9, which is also at 6. So each base is 2, and then the height at any given point of the midpoints come from the 1, 3, 5, 7, and 9. So by doing MRAM, we can calculate that we would estimate the distance here to be 2 times 12 plus 10 plus 13 plus 6 plus 6, which is 25, 35, 47 times 2, or 94, and our units here are in inches. So that's an example using a table. All right. Try these following problems for homework